All right, good morning. Happy Friday, everyone. I have an announcement. One of my students brought up something about the grades. I gave a quiz in Algebra 2, a vocabulary quiz, and she was asking about the quiz in Google Classroom. Don't worry about grades in Google Classroom. You're only worried about grades in Zangle. So anyhow, what you want to do is just make sure that your assignments and everything are uploaded to Zangle. If there's a problem with that, let me know. I'm not recording things a lot in Zangle because the assignments don't really count toward a whole lot. It's mainly the test grades. And so I'm not updating Zangle as frequently. But when I give a test, usually I'll update it right away. So don't worry about grades in Google Classroom. I'm not even looking at the grades in Google Classroom. All I'm doing is posting assignments, and I'm recording assignments in my book. I'm not paying attention to the assignments in Google Classroom. All right, we're going to have an exam on Monday at 8 o'clock. And I'm not going to rush through this lesson to end it, and I'm not going to start a new lesson today. What I want to show you is what I've been doing in the workshops with students to hopefully encourage you to come to the workshops, because they are beneficial if you want to study effectively for an exam. So we're going to do some interactive stuff after I finish the lesson. All right, so I'm trying to finish lesson 5.5. Been on this for a while now. The reason why there were 6 objectives, and so it took a while to get through this. So I've worked a bunch of different types of problems, and one of the last problems I worked, we had to go backwards and write a double angle. You usually want to break down a double angle, but you saw me write the definition of a double angle and go backwards. And then I ended the lesson with, so when you're completely at just the bare bones of sine and cosine and there's nothing left to do, you saw me square both sides. Now, squaring both sides of an equation means that you have to check for extraneous solutions. So we did that before when we had radical equations. When we squared both sides to get rid of the radical, we had to check our solution. Same thing. Whenever you square both sides of anything, even if it's in trigonometry, you have to check for extraneous solutions. So where I ended up was on objective 6, which was use a calculator to solve. And so sometimes you'll have problems that you just can't do by hand. So if you can do them by hand, you are expected to do them by hand because that's what your teachers will want in the future. If you can't do it by hand, you'll have to resort to a calculator. All right, so basically all the previous problem examples were special angles. Pi over 6, pi over 4, pi over 3, 30 degrees, 60 degrees, 45 degrees. What about problems that aren't special angles? Like, what about 23 degrees? We don't know anything about it. You know, what about 17 degrees? We don't know anything about it. So let's take a look at some problems that we can't use special angles for. Okay, so here's a problem that says solve, and you're going to round your answers 4 decimal places, and they want you to give all the answers in this restricted interval from 0 to 2 pi. So here's the problem. Okay, so I don't know about you, but I know nothing about that. And so right away I'm thinking, especially when I see a decimal like that, I'm thinking that I have to use a calculator. So remember what we're doing here. If you wanted to find the angle, don't you have to use the inverse key? So doesn't this really mean x is equal to tan inverse of this thing? Yes, that's what it means. So that's what you would put on the calculator, but let's think about this for a second. You have to be really smart and you have to conceptually know what's going on right now. So if we look at the coordinate plane, we know that, let me look at it over here. This quadrant is positive, positive. This quadrant is negative, positive. This quadrant is negative, negative. And this one's positive, negative, right? Well, between 0 and 2 pi, isn't tangent positive in the first and third quadrant? So wouldn't we have to give answers in the first and third quadrant? Because there's two solutions. One is in the first quadrant where tangent's positive, and one of the solutions is in the third quadrant where tangent's positive. Remember y over x? Negative divided by negative is a positive. So right now you have to understand that there's two solutions you have to find. All right, so the first one's easy because we just put this straight in the calculator. So can you guys do that for me, please? Put in tan inverse of that, and we want to get the first solution. This first solution is going to be in quadrant 1. All right, what'd you guys get? Can somebody open up your mic and tell me, please?
Four, 9.
Yeah. And what's your mode in, Gio? Are you in degree mode or radian mode?
Degree.
Are you sure? Because this says 0 to 2 pi. So the interval is in radians, which leads me to believe that they want an answer in radians.
It's in radians, sorry.
Yeah. So you have to be careful of the mode in your calculator, because if you have this in degree mode and they're wanting something in radians, you will get the wrong answer. So if this said between 0 and 360, 60 degrees, make sure you're in degree mode. But since this says between 0 and 2 pi, that's radians. So you have to be in radian mode. All right. So we got this answer. That's one of the answers. Okay, now the question is this: how do you get the answer in the third quadrant? Anybody have any ideas? It has something to do with the horizontal. So I'm asking you, how would you get this angle in the third quadrant?
Making it negative.
Good try. Good try. Okay, that's not it, but good try. Okay, who else wants to say something? I'll give you a hint. Remember how we had in the unit circle, we had like for pi over 3 or 60 degrees, the ordered pair was 1/2 and radical 3/2. Remember that? And then in this quadrant, it would be the same exact ordered pair, except it's negative. Yeah? Well, if we took pi and we added 1.4929, wouldn't that give us what we want? Because don't we want pi plus a little bit more? So can't we go to the horizontal and add that to get the other angle that's exactly what we want? Yes, no? Yes, that's what we want to do. So to get the other angle in the third quadrant, we want to go to the closest horizontal and add what we want to get the same angle as what's in the first quadrant, but in the third quadrant. So when you add this, you get about 4.6345. And that would be your angle in the third quadrant. And that makes sense, doesn't it? Because if pi is about 3 radians, 3.14, wouldn't 4.6 seem logical to be in the fourth quadrant? So this is 1.4929 radians, because it's an angle, and this would be 4.6345 radians, and it makes sense that if this right here is 1 radian, isn't 1.5 around there somewhere? And 4.6 would be after pi somewhere. Now, this was the easiest problem you're going to have. Here's the question. What if it's not in quadrant 1? What if it's in quadrant 2 and 4? Then what you're going to have to do is you're going to have to find the reference angle and use it to help you out. So right now, this reference angle, which is an approximation, it was one of the answers because one of the answers was in quadrant 1 and one of the answers was in quadrant 3. You know what? Do I like the way I explained that or no? Pi plus a little more. Okay, here's another way to think about it if you don't like that. If that's the angle we found, isn't this angle from here to here going to be pi because this is a tangent period pi? So you can either think of it this way, pi, and then a little bit more, or this might be better to understand that whatever this angle was, 1.429, if you go pi more, isn't that going to give you that other angle? I actually like this better. So you found this angle right here. If you want to find this angle, can't you just go pi? Because isn't it a straight line? So can't you just add pi? Let's do another problem. Do another one. Oh, also, I do have another announcement. I think you saw my remind message come up because I had a student say, Ms. Birch, I just feel like I don't have enough time to finish these exams. And then I was working with the student one-on-one. And I was like trying to do some of the online problems, and I kept messing up, you know, like, oh, it should have been a fraction, oh, it should have been a radical, and it was taking me time to put things in. So I wish you guys had told me earlier, you know, that you feel like you don't have enough time, because I want you to feel like you have enough time, especially if you know how to do something. So I'm going to start giving you a little more time to take the exam. In fact, I'm going to start giving you a half an hour more. Okay. So that's because I don't want you to feel like, oh, Ms. Birch, I didn't finish 3 problems, because you had to take time to work the problem, but then it took time to try to figure out, you know, how to put the answer in the computer. So anyhow, I'm glad somebody told me at some point, but I'm going to give you more time. All right, let's do another problem. All right, look at this. Cosine of x equals negative 0.4317. All right. First of all, we need the reference angle, and that's not it. So negative 0.4, 4/10 of a radian, that's not even 1 radian, is in the 4th quadrant, right? So this thing is in the 4th quadrant somewhere. I don't know where, but say it's there. Well, in order to do this problem, we want cosine to be negative. Well, guess what? Cosine's not negative in the 1st quadrant. There's a couple things going on here. And you really have to conceptually know what you're doing, because all the problems are going to be different and you do not work them all the same way. So let's just, before we start, let's just figure out what we're doing, what they're giving us and what we're doing. All right. They just gave us an angle in the 4th quadrant. Cosine is positive where? It's positive in the 1st quadrant, and it's positive in that quadrant. So once again, we're lucky, because we're going to have an answer already, I think. Oh no, I'm sorry, we want cosine negative, my bad. Cosine's not negative there. So cosine's not negative there either. We want cosine negative, right? Okay, so this is where they're giving us the answer here. And that's not going to help us. Cosine is x, right? Oh, that was wrong. Okay, yeah. We want cosine negative. So cosine, we want answers here, and we want answers here. Not here and not there. So just keep that in mind, that whatever we do, we don't want answers over there. We want answers over here where cosine is negative. Okay, the first thing we're going to do is we're going to look at the reference angle. And so what we want to do is we want to take this and make this positive. Okay, and now we want to find the angle. All right, so we're going to say x is equal to cosine inverse of this thing. This isn't going to be our answer. Okay, all we're doing is finding the angle in the 1st quadrant. Okay, so somebody tell me, what is cosine inverse of 0.4317? This is going to be in quadrant 1. What is it? You're in radians still. What is it?
1.2. I mean 1.124.
4? Okay, that's not the answer. So what we have to do is we have to put ourselves in quadrant 2 and quadrant 3. Now the question is, if we just found this reference angle, how do we find these guys? Because aren't those the answers? I'll show you over here. We just found this, but we don't want that. Don't we want this and this? So how do we find them? For example, how would we find this one? What's the horizontal? Pi, right? Well, how could I get that? Using pi. So this is the angle in the first quadrant. I want this angle. How could I use pi to get it? Go ahead, I'm listening. Couldn't you subtract that off? If this angle right here is 1.1244, isn't that the same? If we subtract off 1.1244, yes, that's how we get it. So you take pi minus that to get